Can you hear me? Yeah. So I'll do it in English. And so I'm a scientist, and I'll tell you what a scientist is just to be very brief. We're in the business of discovering things and solving problems in a way that is irreversible, which is really cool. It takes a long time, but once it's solved, it's done, and we don't need to deal with that anymore. So we don't do patches. We really try and strive to do that. We don't always achieve to do it, but that's our profession. So what I decided to do actually is to tell you a story of a puzzle that we're starting to solve, and I think it's terribly important because we apply this methodology to something that has implications for human health. So if we manage to solve important problems that have to do with human health, well, perhaps we'll be able to treat diseases in ways that are different, the diseases that we cannot treat. And it's very difficult to talk to you guys because you're human beings. And this is the laser. And I cannot tell you DNA, cells, genes, interaction, signal transduction, kinases, phosphatases, ubiquitinases, because I'll lose you in a second. So I'm not going to touch on that, but I'm still going to try to tell you my story. So I'm going to try to go very large and tell you how groups of people socially interact, individuals interact if threatened, and then to take you how we interact with microorganisms if threatened. And there are two ways to do that, and you will see that one of the ways is not obvious in both cases. So if you're a group, social, cultural group, and you have an innate sense of identity, right? You associate with your friends, and if that gets threatened, you react. You have to react, because if not, you lose your identity. So you have two options. You eliminate the threat, and I'll call that resistance, or you try to cohabit with the threat somehow so they can still preserve your own self, and I'll call that tolerance. So I'm going to try to give you an example. You can imagine a soccer team or a racial group or a country, and get threatened by another soccer team, another racial group, or another country. And the option number one is to engage into war. Very easy. And actually this happens all the time. You see people from one team in Porto or Lisbon literally killing other people from the other team for no apparent reason, but because they feel threatened by the opposite group. I'll give you an example of wars. For example, George Bush decided that the best way to deal with the Arab countries was just to almost nuke them or annihilate them. So that's option number one. Option number two is more of a Barack Obama type of option. So you engage into dialogue, try to understand in a way that you don't lose your own identity if you're a country, but you don't need to annihilate the identity of the other either. And you try to reach a compromise that you're going to change, obviously, because you've got to be influenced by the person or the group that is in front of you, but you still preserve while changing. So this requires that you're not really afraid of changing, which is a feature that not everybody shares. Anyway. Now, there's option number three, which is a mixture of one and two, which is the politician. You engage into dialogue, but in the end, you try to kill your enemy. And that's very used. Now, I'm going to try to go a little bit more into individuals, and I'll get to cells in a second. So the same exact thing. An individual has a sense of physical integrity. If that gets threatened, you can go into resistance or tolerance. It's the same modus operandi. And I'm going to give you an example. You get threatened by a guy who's trying to steal you, and he has a knife. So option number one, you take a beer knife, George Bush option, and you just slaughter that guy. There's a risk, actually, is that if you're not very efficient, you risk, actually, that guy kills you. So there's a trade-off there that one needs to compromise, perhaps. And there's a second risk, is that you might even change as a person in the process of killing the other person. So you might even change, but I won't get into that. Now, option number two is, again, you engage into dialogue. You're going to lose a little bit, but you might get your wallet lost, or your iPod, or if you have an iPad, which I wish I will have one very soon, you might lose that as well. But you preserve your integrity, so it's a fairly good compromise. Or you can go on option one and two, which is pretty cool. You talk to the guy, and eventually you kill him. Right? So this is exactly what we do with microbes. It's exactly the same thing. We're individuals, and we're threatened by a little microorganism in a way or another. And we've been, for years and years, studying option one, which is how do we kill the microorganism? Which is the only thing that we thought we were doing against, which is resistance. And I'll tell you a beautiful story, I think, of tolerance. And how do you learn how to cohabit with that microorganism, and the tremendous implications for medical intervention that this will have. So infection by a microorganism, I just told you, the microorganism is threatening your own integrity, right? So it's a pathogen. So you have an immune system that will kill the pathogen. I'm not saying that that's not useful, but I'm going to tell you that you're going to need to learn with that learn how to interact with that microorganism in a way that you just don't collapse, even if you're killing it. And actually, we go very often for option 1 and 2, which is you try to collaborate, but as soon as you can, you'll just kill it. I kind of like this third option. So let me give you a little bit of diagrams, just to get the same message through, but through a diagram. So on the left side, that funny word, microbial pathogen, is an infection. So it's a microbe. It invaded your skin, for example, or your lungs. Flu. You can imagine this as being flu. And you are on the right side. You're the green. You're the infected individual, and you're getting sick. So we all know that the microbe is causing injury to the individual. So it's going to do something which is harmful to the individual, and that's why you get sick. Right? And we also know that you have an immune system, which is this big word that we don't have time to describe, but you have a set of cells and molecules that are all devoted to recognize the pathogen and just go after it and kill it. Now, we came to realize over the years that actually the process of killing can actually be very bad for yourself. It's the, I won't go into that, but if you go too strong, you actually might harm yourself more than you harm the pathogen, because you're using the same weapons to kill the pathogen that could kill you. So we came to realize that, and we came to realize that there must be another mechanism to make this balance go through, because in most of the times, this works. So there's a second thing that we can do, which is actually to attack the injury caused by the pathogen, but we don't touch the pathogen itself. So if you go through this arrow, you never touch the pathogen. And yet, you're enforcing a prevalence of your health status here. And this seems very simple, but it's completely unknown. And you could also do it here. So you're limiting the injury of this response here, of your weaponry if you want, but you're not touching the pathogen. And this, actually, in biology, is mediated by genes that encode for proteins that have functions in cells. So our whole aim is to find out what the hell are these genes. Do they exist? And if they exist, can we modulate them to treat? Because if we enforce this very strongly, we actually achieve, I'm going to do it in a few slides here, that the injury goes down, that the pathogen will have time. This is option 1 and 2, because you give time for the resistant to keep going. Eventually, all this will disappear, and this will disappear, and you get back to be an healthy individual. So right now, this is like campaign promises. I haven't shown you anything that is likely to be true. But, so this is yet another scheme that will tell you how it works. So we're very used to this. If you get a pathogen, a microbe that infects you, the more you get, the worse you get. Right? This is health. You get more and more and more sick. So how do we treat these people? We get rid of the pathogen. Right? We go this way, and we expect to go up. What I'm telling you is that you don't need to go all the way this way. You can go just up here. You can keep the same level of pathogen and increase the health status. And this is very important for diseases that have no treatment. And one of those diseases is actually malaria. So malaria, I'll just tell you very briefly what it is, and then I'm going to tell you why you die from it, or what's the symptoms of it. So it's given to us courtesy of this little guy here, which is a mosquito, and he's infected himself. He's not very happy, and he injects I'll have to give it a name. It's called Plasmodium, and it goes into your liver, multiplies there for a couple of days, weeks, and then he goes into the blood. And when he gets into the blood, that's where you start getting all the symptoms, all the clinical symptoms of the disease. And he multiplies inside red blood cells, but red blood cell is small. So once you get to 16 little animals inside a red blood cell explodes, and you infect more and more, and you do cycles of these over and over. How do we treat this? Obviously, we treat this by killing Plasmodium, but that doesn't work. That doesn't work because you get 1 million people that still die every year, and when they get to the emergency room, the medical doctors say, let's kill the Plasmodium, but the child will still die. So a very different way to see the disease is the following. We used to, everybody that talks about this type of diseases says it's a threatening disease, it kills millions of people, and you get the idea that Plasmodium is your thief, is a nasty molecule that is just, God on earth, beauty and mighty, invented Plasmodium just to kill you. And that's not true, actually. So I'm going to drive you through the numbers, and you will understand that we have a tremendous tolerance against Plasmodium. So if 100% of people in a given area get infected by Plasmodium, only 50% of those, if they get a bite from a mosquito, only 50% of those will get the mosquito in their blood. So there's a tremendous protection there. We have no idea what it is. Now, from those 50%, only 12% will actually become sick. They will go to an hospital and say, I'm not feeling very well and I have fever and all that. From those 12%, from the original 100, then 2% develop severe malaria. Then you're reaching threshold level. You might really die from it. And only 1% dies. Now, let's keep the numbers. 300 million infected a year. So all the numbers become staggering and huge. 1 million people die. But this 1 million is a very small fraction, is less than 1% of the people that get infected. So basically, 99% of us actually survive very well to Plasmodium. So instead of trying to understand why the 1%, why the freaks die, you can actually ask, why do the 99% survive? And they survive most probably because they have a tremendous tolerance to Plasmodium, which will indicate that those that die have defects on the mechanisms of tolerance against Plasmodium. Okay? So that's the premise of the work. So just to close up the story, and I'm not going to give you the genetical data that proves this, but it exists. What we're trying to do here all the time, this is again your health. You get infected, and your health status goes down all the way here as you get more Plasmodium in your blood. What do we try to do? We try to increase resistance. We try to vaccinate. Vaccinate is just a very old trick that we all discovered, that you can actually ask the immune system to recognize something that is equal to Plasmodium, and when Plasmodium comes, you already have a tremendous resistance, and you just go after it and kill it. It doesn't work. And so far, it doesn't work. Right? You have the same 1 million people dying, but millions go into it. Now, the other thing is that you can use the antimalarial drugs. They work. But they don't treat these severe cases. You cannot give a drug that these children will stand up and go. And most probably what you're missing is the other side. You're missing this side here. You're missing, I'm not saying you should not clear the pathogen, but what you're missing is to understand what are the mechanisms that make you go from ear to ear and actually generate drugs that actually can tackle that. And this is all our research, and I think I'll finish here. I think I was much shorter than 15 minutes, no? That's it. Thank you.